Heyo! Happy Thursday, folks. Sorry, we're getting a little bit of a late start here today. It's one of those days, apparently. How are you fine folks doing? Hey, Crow. Good to see you, my friend. Alright, we got to talk more about threads today and wrap that up. And that's about all that's on the agenda for today. Let me double check. I think that's all we got. We'll grab this one here. Let's see. Take a little peek here. Threads, yep. Finish that up. Awesome. So we've got the final project we can get started on here. would definitely encourage you. Lab 11, yes, our Lambdas lab. Thank you. Talk about the Lambdas lab. Let's take a peek here. Right, so we're building out our own method event handling here with Lambdas for our setting on action here in a Javafx application. Let's give this one a peek here. Let me start a new project. We'll do a Javafx application. Make sure we put this in the right folder here. And this is Lab 11. All right, so I'm going to do it in a new window. I'll leave threads there. And then so we're not doing any of this fxml. We don't need to do any of the fxml here, right? Because we can do it all just in code if we want. So let's go get rid of this one. And we can get rid of this one. That one. All right, I'm going to get rid of our controller. Get rid of the view. All right, and then actually let's just go, we've got our previous examples. It's probably easiest to copy off of just to give us the bulk of it there. So we'll grab those ones. All right, where do we want Lambdas? So we're going to start with that anchor pane. And yes, we got to add a new import here. And then we'll go grab some labels, V-boxes, buttons, and we want add those ones. Yep, add some more imports. Then we need to have this one as a class level label variable here. Does this one want to suggest it? Here we go. We can make a field label in hello application. We'll generate that one for us. Love when it writes the code for us. And then we'll go and set the scene at the end here, given the pane. So we are going to suggest a size for it here. I think that'll probably work. Should be okay. And then to do a button with a lambda here, we'll do our button with a lambda. We'll import a button here. No, not Cortana, not you. Probably should just turn it off. I don't think I ever used that. But it is kind of fun. All right, so we got one button at least here. That's a good start. We're going to make 3 buttons. One for rock, one for paper, and one for scissors. Regardless of which one we pick, we'll pick a random choice and display a winner. So we've got the label here, so we'll make this one a rock button. And then what do we want to have it do when this runs? Well, this one needs to, for us to be rock, and then we need to go see if the computer is going to win or not. Right, so we probably want like some sort of helper method here as well, so we can have a private static void play rock paper scissors, and we need a string for the user's choice, maybe. We'll do an int for the user's choice. How about that? Int user's choice. So then we need to get a computer choice. So int for computer choice is going to be math.random, and we want to multiply by 3, so we'll get 0, 1, and 2. Right, so we want that. as an int. Make sure we do the multiplication first. Turn it in an int. Right, and then if they match, right? So if our computer choice equals the user choice, we'll take our label. We'll set the text to tie. Is that a label? 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 Oh, sorry, this one's not static. Sorry. There we go. Okay, and then else if my user choice is equal to 0, so if we're a rock here, right, so we'll call our method here with 0 for rock. So that's a little ugly here. So why don't we add in, how about we'll have a private static final int rock is 0. There we go. We'll put some nice names to it here. Rock, paper, and scissors. We can pass rock. There we go. So if the user's choice is rock and the computer's choice is equal to paper, nope, equal to paper, right, that's one way to lose here. Or, and I don't think we need these here because of order of operations, but it's always better to be explicit here. So then another way to lose will be if we are paper and the computer is scissors. Scissors. And then the last way for us to lose here is if we are scissors and the computer is rock. Right? So if any one of those happens, we'll say you lose. Lies, you lose. Is that font large enough? Let me zoom in a little more. Yeah, it doesn't have to be, but I think this will be easiest for us here as a separate method because the same thing happens, but the buttons will just tell us if we're rock, paper, scissors. And if we didn't tie, we didn't lose, we can just, we know we must win. Okay, so then that button will be for rock, and then we'll do another button for, this is my rock button, I guess. Rock button. And then we can have a paper button. Yeah, we just have a private label. That way, if the label is a class level variable, other methods in the class will have access to it. Right? If we only define it here, then the only place we can access it is here in the start method. So it's just a way so we can have access to it down below in our helper method. This will be paper, paper, and scissors. Scissors button, for scissors button, for scissors button, for scissors button, scissors. The word scissors has lost all meaning now. Okay, so we'll give them the different buttons, and then we'll be able to tell them tie, win, lose. Now, this doesn't really give us the most information, because maybe, like, do we want to say what we were, or like you played, or we could do that too if we wanted. So we could take we could say, hey, if here before we even do any of that. So let's say before we call those methods here, because I don't have to do another if else if here depending on what the user was. I want to see, can we do it here in the lambda, right? And we can, right? Lambdas can have multiple lines. Totally allowed to do that here, right? So before I play that, I'm going to take my label and I'll set text to you play rock, right? So we can have multiple lines in these lambdas if we want here. And then what we can do with this one, right? Say you play paper, and something happens, and you play scissors. And then instead of setting the text straight out here, you want to set the text to label.getText plus new line tie. Right, so if we're setting the text to whatever the text currently is, we can just keep on appending to it essentially. So we'll let the lambda start with, okay, you do this, you do this, you do this, and then we'll throw this in for win, lose, or draw. Right? Because we could have done that in here too with just an if. You know, then, okay, if the user's choice was 0, put in you played rock, but this is just an option. Just a way, right, we can have these multiple line lambdas, these anonymous methods here. Let's give it a run, see if it works for us. Gotta get my coffee here. All right, rock. We play rock, we lose. Rock, we win. Rock, we tie. Okay, so those ones seem to work there. Paper, win, lose, tie. Scissors, win, lose, tie. Yep. We can play whichever one we want. Not the most exciting game here, right? But it's okay. We'll get the job done. That part makes sense? For our lab? Go commit that one to GitHub here. $21.51. And here's lab 11. All right, awesome. Close that one down. All right, so threads. We were having some fun with threads. So we left off with this prime count not working here, right? Where we lost updates, right? We didn't get as many counts out of our static value here because as the thread was accessing it, another thread could be changing it at the same time. That's right, Ernestinance. Drink that coffee. Drink that coffee. I gotta make another pot still. Oh man. One of those days, friends. Hope you're doing alright. This weather's just been nuts. I want spring back again. It was nice when we got like a little taste of it. So, to avoid this sort of issue here, what we can do is instead of us accessing this directly here, what we want to do is we want to use this idea of a synchronized method. And what synchronized is going to do is behind the scenes, Java will make sure that only one thread gets to touch it at a time. So I'm going to get rid of this as a public static prime count here. And then we're going to have a private int for prime count here. And then we're going to add get and set methods here. So we'll generate. You know what? Let's just add just we'll add both. We'll add both here. So we'll generate both getters and setters for prime count, and then we're going to add the synchronized keyword. We'll say synchronized get prime count. Now, probably not as important that get is being synchronized, because you're only getting the current value out. We don't necessarily need to make sure it's happening one at a time. But setting the value for sure is really important, that only one sets it at a time here and has access to it. So, and I think we're probably even better off here. What did I do? Oh, sorry, void. It's like it was a red line there, and I changed that from void. We might want to just have this instead of set here, because we're still going to have the issue where I'm going to try and get the old value and set the new value here. So instead of setting prime count, we'll say increment. prime count. Increment, it would help if I could spell that right. Name 2. Is that the suggestion? There we go. And then we'll take prime count plus plus. So we can just increment it here. So then in my threads, I'm not going to take prime count equal prime count plus 1. We'll say prime count dot, oh, and these we should make static, sorry. So I don't need to have an instance of it. So static, there we go. Prime counter dot increment prime count as a method here. And then we want to, when we're done here, in our controller, get prime count. I misspelled that one wrong too. Calculated. Man. Spelling is hard, friends. Alright, so let's give it a try. So we're going to use this synchronized keyword here. So synchronized ensures that only one thread access this at a time. Now, we do need to be a little bit careful with that, because what that means is if I have 10 different threads running, each thread can only access it one at a time. The rest have to wait for it. So depending on what we're doing, it might slow down our thread. So threading is really tricky here. But this is going to make sure we don't lose any updates. So it's important, especially if we're doing anything where we like have all the bunch of threads talking to one particular class here. You don't want to lose any of those updates. Let's see. Just thinking about it. All right, do we get it? And now we get the same number. Not too shabby. Right, we get the same number here. Was it a little slower? It might have been a little bit slower, as all those threads had to wait for doing those updates. I think it was going mostly pretty well there. What do you think? Okay, so it was synchronized. And then the other thing we wanted to look at is another way you can make a thread. So the other thing you can do, instead of inheriting from thread, you can implement. So here's another thread example with interface. So for this one here, what we're going to do is we're going to implement the runnable interface. So it implements runnable. And if you implement runnable, then you can be handed to the thread class to be run. So you still have the run method here. Let's see, do we need, you can still add a bunch of this stuff in here, but run for sure. And then, so it's not thread.getName, it's not a this.getName now. So to get your thread's name, we need to say, I want thread.currentThread.getName. So because we're not an instance of the thread class, we have to go ask the thread class for what the currently running thread is to get the name back out. Then we can still have constructors here. So public thread example with interface, given an int for start value and an int for end value. Here, we'll have a private int for start value, private int for end value. We should just be copying more of this here. There we go. You can just copy all of that. Why not? Why not? And then we'll just change the name. Okay. And then we need the isPrime method. Sure, we'll add that in. Why not? Now, there's an easier way to do this one too. We can improve this isPrime method here. So I'm going to real quick say, hey, if n equals 2, we're going to return true. Okay, that's my quick check here. And we also want to have a quick check. We'll say, hey, if n is less than 2, we're going to return false. So 2 quick checks here for less than or equal to 2. After that, I'm going to start at 3, and I'm going to go up by 2 at a time here to get odd numbers. The other cool trick we can do is we can go to math.square root of n with math.ceil square root of n here. So when you are trying to find out if a number is prime or not, you don't need to go to half the number. You'll need to go to the square root of the number. But I want to make sure we round up here because this is the last particular value here because we're dealing with integers here. So if I were to check to see like if what's a good number with has a good root, like if 64 is prime here, right? We don't need to go out and check any higher than 8. Right? That's just a quick way for us to check here to see if it has any factors. All right. Give that a little format. So 2 quick checks here, and then we can start just checking the odd factors here. We don't need to check any of the even factors because only the number 2 will be true, right, if it's prime. So one last check here. So if n is 2, and then we can check, hey, if n mod 2 is 0. That's right, add one more check in here. We're going to return false. False. Okay. And this one, it's just bothering me here that it didn't have the curly braces. All right. So less than 2, not prime, is 2, yes prime, is divisible by 2, not prime. Then we'll check for odd factors. And if we can factor one out, we're not prime. If we've done all that, we're going to be true here. All right. And then the last one here, we need this again. We're going to replace this one here with this. Okay. I think that took care of all the issues with this one here. Now, the benefit of implementing Runnable rather than inheriting from thread is that, remember, you can only extend a single class. You can implement as many interfaces as you want. So I can still do other things with this class and have other parent classes or super classes that are not thread here. So you're a little bit more flexible here, have other choices for inheritance when using the interface. Inheritance. Inherit. There. Inheritance. Okay, got the I in the wrong spot. That's kind of the benefit there. Okay, then to use these threads then, where's our controller here? Here we go. So instead of saying here, I want a new thread example here, we need to say, hey, I want a new thread, and I'm going to give it the new thread example with interface. So the problem with that, though, is I can't get the prime count out directly. So we want to, we need to track both, don't we? Let's see. That's kind of a bummer. So it's maybe a little bit trickier to use some of the other pieces inside of it here. So let's leave all of those ones there. Okay, so we'll do the right button. If the right button gets clicked, we'll do this one here. So let's see if we can't repeat this one. So then we're going to use a regular thread here. We'll say, hey, I need a new thread. And the new thread that I'm going to give a new thread example with interface. So you can give thread an instance of something that's runnable when you create a thread. So a thread can be given something that implements runnable here. And then this will be an array list of type thread here. Oh, this is kind of annoying here to have them both, but that's okay. And then we'll have an array list of type thread example with interface. These are the prime counters. New array list. Okay. So then we'll add both things here. So I can't just create a new one of these here. Let's do that. So we'll say, hey, I want a thread example with interface. This is the prime counter equals a new thread example. And we can give it the prime counter. We can add that to our thread here, and then we'll add our prime counters, add the prime counter. And then we want to go for each. So now we want to go by index here. So for index is 0, index is less than my thread count, threads.size, index plus, and then we'll say I need threads.get the index.join, and then I need my prime counters.get the index.get prime count. All right, so I need to track them separately here because this is the class that's doing the work here. The thread is the one that has all the thread options. So it's maybe a little clunkier here to have to add those in, but it should work okay for us. Let's give that one a shot. Uh-oh, something's red. What's red? A semicolon. Yep, okay. Just a semicolon. Why is this one red? I don't think it's actually errors, is it? Okay. Let's see. So that should happen on the right button. And that was a lot faster. Look at that. So fixing up our isPrime method was a lot nicer here, right? Going only to the square root rather than to half. We're only doing by every other, just the odds. We've got a quick, hey, if it's even, we stop right away, right? And then let's see, so this is not, so this loop will never run here if n is 1, right? Because when we say, hey, I is starting at 2 and it's less than n divided by 2, it's going to return 1 is prime, and I think that's why our count was off. You notice this is 98 instead of 99. Because in our other one here, we're doing our little check here. Hey, if you're less than 2, you can't be prime. Because math people can correct me if I'm wrong, but a prime number is supposed to have 2 factors, 1 and itself. And 1 only has 1 factor, because it is itself. So it doesn't have 2 factors. So I think we don't usually consider 1 as prime. So this little example that we stole for isPrime, didn't we get that from somewhere here? I feel like we got it from somewhere. Did I not cite my source? Uh-oh. How did I not cite my source? We wanted a bad one. Oh, sorry. We started with a bad one, but we cleaned it up a little bit. I forget. Forget what we did here. But that's okay. Right, so that one definitely runs a little faster here with how that one works for us. Right, with it being a little smarter with our isPrime check. Okay? So, again, maybe a little bit more work kind of managing this class here and then handing it to thread if we want to still use these thread pieces here. Like, hey, I want to wait for them all to finish. I want to go join them when we're done. Right? Join waits till they're all done so we can get all those values out here. Okay. How you folks feeling so far? Clean them up just a little bit. There we go. All right, so we'll do, so this is threads via Runnable for this one. So it gets the same job done, just allows us to work slightly differently with our code here. So if we wanted to, right, we could extend other classes here and have some other options to what we were doing with it. Okay, awesome. So why don't we try here then? Let's do a little lab for threads. I wonder. Usually disk operations are slow, so it's nice to kind of put those into threads so we can continue on while we wait for that. But there's only, I mean, modern drives are actually faster-ish, especially if you have a solid-state drive. You're not going to be waiting quite as long. That one's a little harder to see here, but we can do a small lab. You go set up a new link here. Nope, that's not what I wanted. That's the one I wanted. There we go. So do one last lab, 2151, winter 2022. This is lab 12 then at this point, right? Lab 12. Auto finishes up here. Oh, we can close out our program here. Close that one down. Wind, Unity, Java template. Feedback pull request. There we go. All right. One last lab. Twelve threads. Now, do you want to do this one with Javafx? Go for it. If you don't want to do it with Javafx, that's perfectly fine too. Either way, it's up to you here. Let's go add a new lab. So the problem is if we do it in our console application, oh, it should be fine to do in our console application actually. That'll be okay. So in labs here. All right. There's our link, so please submit the feedback pull request URL. So we're going to sort of take what we've done here and modify it a little bit. So we're going to modify the thread example to be a console application here. So we're going to get rid of the Javafx stuff. We want to be able to have these threads here, and then we're going to ask the user for how high of a value we want to count the primes up to, and then ask the user for how many threads they want to use. So in our example then, oops, I had actually closed that down already. Let's see, we were going through and doing, not lambdas, threads. Nope, not that one either, source. This one, my goodness, friends, we'll find it here. In our controller, we were going through and doing the loop ourselves here, saying, okay, let's do 10,000 at a time. So what we want to do is we want to ask them, okay, well, what is our max value going to be here? And then how many threads we want to use will determine max value divided by that is going to be what we need to increment by. So if I want to count up to 1,000,000 and I want to use 10 threads, I'm going to do 1,000,000 divided by 10. I should be counting by 100,000, setting all those threads up here. Does that make sense? So in the for loop, we're creating threads, use the max value provided, and the increment is the max value divided by number of threads. increment. Increment. Okay, there's an E there. That's what it is. Right. So if we're using threads here that are not in Javafx, we can go and print stuff out to the console. Right. So for we had issues setting labels with Javafx, right? But we were able to print to the console no problem. So we could see some of that logging. Now, logging is probably the wrong word for it here, but we could see in our threads then, right? We could see all those messages we were spitting out to the console, because threads can print line as much as they want, not a problem. So this part should be okay here. All right, and we'll give that a shot. Use the threads, have a little fun with them here, and we'll go from there. Okay. All right, so we'll do that one. That'll be our lab. Any other questions, thoughts, or concerns? We're going to get started on Yahtzee here, for sure. We've got till the end of the month to get this one done here. Now, you definitely want to spend some time thinking about how this is going to work, especially with multiple players. You don't want to have to do more work than you need to. So the goal here is, as you write your classes, right, the classes should be completely separate from the user interface. Right? We want to write our classes so that they can work regardless of where they're used. You just interact the class with the methods. So we need a way to get values out and to pass, hey, this is what the value is, or this is what I want to do, this is the action I want here. Right? So that we can hook up buttons to call those methods, and we can hook up the buttons and whatever to set all the display things. So the user interface is going to have, okay, this is where I'm going to display the scores, this is where I'm going to display all this, but like all the logic behind, okay, here's what your roles are, that needs to happen in our business logic classes. Right? It'll make life a lot easier for you, especially if you're dealing with multiple players here. Okay? So should we build out the rubric? Let's make a new final project rubric. So this is 40 points total here. And then I've talked with a few of you. I don't remember if we mentioned this or not, because remembering things is hard. But if you didn't do as well in the individual projects as you had hoped, what I'm going to offer is I'll take your final project score, assuming you did well on that one, and replace your worst scoring individual project with it. So if you can get 100% on this final project here, then whichever individual project you did worst on, I'll just go replace it with that 100%. Does that make sense? So let's add some, oh, not a grouping. Yeah, that's not what I wanted. Let's add criteria. There we go. We'll add some more of these. And one more. Okay, so 8 different sections here. Right? So we're going to have the some points here for how it's designed. Right? So first, so we'll have UI is separate from game logic classes. So the UI shouldn't have the game logic, right? The UI needs to work with the game logic classes. However you want to break those out here, you get some points there. So we're able to roll dice up to 3 times, and this up to 3 times, the first roll counts as 1. So really like 2 more re-rolls. Roll / hold. So if you want to roll the dice, all 5 again, go for it. If you only want to re-roll one of the dice, go for it. So we need an ability to be able to do that here. We need the scoring shows potential score. So like that Yahtzee game said, okay, this is what you would score if you were to score it in this category. We get points for doing that here. We're going to have the upper scoring section. So that one is relatively straightforward here. And then we're going to have the upper score bonus here. So 10 points for the upper portion, 5 for being able to score the upper section, 5 for calculating the bonus. This one is, hopefully a gimme. Here, that one's probably one of the easier things you can do to calculate whether or not you have a bonus here. And then we'll have the lower score section. and we'll have 2-player mode. So I'm only going to put 5 out of the 40 points here for the 2-player mode, where like we'll alternate between the 2 players. So if you want to focus on just 1 player, that's an option if you don't want all those points here. Right? As we're trying to work through these as we go. So we've got the design, we've got rolling the dice, we've got showing scores, upper, lower score section. What's the last piece here? What am I missing? So once it's done, we'll allow them to start a new game. So allow a new game to be started. Okay? So like after it's done or at any point, they can just reset, start new game, that sort of thing here. Okay? So and the lower section had the 3 of a kind, the 4 of a kind, so it had a bunch of different pieces here that'll all make up whether or not it's scored right. I'm feeling bad about that bonus. That's okay. That's okay. Make that work. That sound okay? This is Java. Oh, that's fine. We'll leave it there. Okay, so we'll add that for the rubric. And we can go from there, okay, folks? Any other thoughts, questions, or concerns? Awesome. We'll get working on that. And then, let's see, what do we have for next week then? We got a little talk on design patterns, annotations going on next week. The week after that, I don't have any plans for streaming for these 3 days. So set aside, folks can meet with me. Happy to get you pointed in the right direction, get you unstuck if something's not working right here. But spend some time, design, think about your classes, and we can go from there. Did we have next week that project 3 is due, right? Our last individual project. So I think that one got backed up a little bit here. So, yep. Next week we can talk about that one as well, the project, database project. So if you're having trouble, I think 1 or 2 people were still having some issues with databases. Let me know. Someone who's using a Mac, I think, was having an issue. So let me know. We can hop on a screen share session and get you going in the right direction. So we can go from there. All right, folks. You take care. We'll see you next week if I don't hear from you before then. And I'll see you around. Bye, everybody.